Hey, good morning, everybody. This is Mr. Ainsworth here, and we are in Algebra 1 here in 2024. We are going to get into Unit 2 review, linear and exponential functions. And so get your lesson up, go into Canvas, get your lesson already, and notice that I have Desmos over here off to the side. So pull up your doc and bring over Desmos over here, and so we can begin, okay? Because you're going to need it, okay? When you deal with exponential functions, especially, you need a calculator. All right, so let's get right into it. All right, suppose we had $800 initially, okay, and that's when we get started. So let's bring this down here. We have $800 initially. That's your initial, or we say starting value. You can use either word, right? Okay, so that's your initial starting value, and you put that and you invested, okay, and invested your money in a bank that earns 15% interest each year. That's amazing. And if you actually did this and you talk to your parents about this, they would say that is an amazing rate of return. Okay. And with that right there helps you out with finding what's called the growth rate. So we need to talk about that. And it says here, show how your money grows each year for the first 5 years. So notice that we have years here, and then we have over here, we have the investment. So how much you earn over time. Okay. And so what we need to do is figure out the growth rate. Well, if you invest in a bank and they actually give you 15% of the year, well, we know that at the end of the year, okay, end of the year, okay, what we're going to do is we're going to have 100% of our money plus that 10%, the 10%, or excuse me, 15%, sorry, plus a 15% gain. I mean, this is an amazing rate of return. So we're going to have 115% of our money at the end of the first year. That is amazing. Okay, and so you have to remember that 150% means, let's see, percent. If you from grade school here, that means, all right, per 100, per 100. And so if we have 115%, we have 115 per 100. Okay, and here we go. Get your calculator ready. If you don't remember how to divide by 100, God help you. But oh, no, just kidding. All right, so you move the decimal place two places left, right? Take 115 divided by 100, and you get 1.15, and that's your growth rate. Okay, so we have the b, the base in our exponential function, which looks like this, by the way, y equals a times b to the power of x. That's your exponential function. I'll even write it down here. So exponential function that we've been studying for quite a while is a times b to the power of x. What would that function be? Well, we need to know the growth rate. So the growth rate is 1.15, which means we take our money and we multiply it by 1.15 or 115% every year. So let's do that. So let's take this 800 and multiply it by a growth rate, 1.15. Bring your calculator in. All right, so there we go. I'm going to take 800, all right, and multiply it by a growth rate, 1.15, and notice we have 920 bucks at the end of year one. And all you do, guys, is keep on multiplying this by the growth rate every year, and you get to use your calculator because we're dealing with exponential functions here, and you have 1,058 bucks at the end of 2 years, and then you multiply it by the growth rate again. All right, you have $1,216.70 at the end of 3 years. And then you multiply by your growth rate again. And so now you have $1,399.21. You got to round to the nearest hundredth there. So you have to know decimals and you have to know how to round to the nearest penny. Okay? So nearest penny. Or what we say, the nearest hundred, right? Because there's only 100 pennies per dollar. We don't have any smaller amount of currency, guys. And then you multiply by the growth rate again, so 1.15, and you have, at the end of 5 years, you have $1,609, and look at that. Let's round that up to 9 cents, okay? And so right there, what we just did is we used the growth rate, 15% increase each year. Okay, this is an increase. That's what this means. So it's an increase each year. So at the end of every year, we have 115% of what we started with. All right. now that we have your b value, what you call your growth rate, we know the initial function looks like this. Y is equal to whatever a is times your growth rate, 1.15, to the power of x. And if you don't remember that the initial value is when time equals 0, so we know just by looking up there, we should know by now because after experience, a is 800. What you could do is take this ordered pair. Let's take this one here. All right, and substitute it in. So when x is 0, we have the y is 800. So x is 0, y is 800. And if you substitute that in, and we did this in class many times, so if you go back to your lessons, we solved 800 is equal to a times your growth rate to the 0 power. Okay, I put 0 in for x, right there. 800 in for y, and then you simplify and you get 800 is equal to a times 1, because any number to the 0 power is 1, which means a is 800. That's your initial value. Okay, now if you know that it was 800 in the beginning, then you don't have to do that, right? All right, but now we know, so let's write the function. So y is equal to 800 times your growth rate. Oops, I'm sorry, not 1.1, but 1.15. All right, to the power of x. There's your function, your money function. Now we get to use it. So when after 10 years, x is 10, we have y is equal to 800 times 1.15 to the 10th power. And of course, this is a exponential function, so you get to use your calculator here. So let's do that. And so we get 800 times 1.15, all right, to the 10th power. Look at that. And so how much money do we have after 10 years? We have $3,226. No, $36. Sorry, got to read correctly here. $36. And if you round it to the nearest penny, that's 45 cents. Okay? Now, predicting using the function going into the future here, if x is 25, all right, what do we have? We have y is equal to 800 times your growth rate to the 25th power. And again, this is a calculator problem, so use your Desmos here. All right, multiply it by your growth rate, 1.15, to the 25th power. All right, holy cow. Well, you got to put the right numbers in, so let me fix that. There we go. So what do we have after 25 years? We have looks like 26,000. All right, $335, and then you round it to the nearest penny, 16 cents. So look at that, guys. Look at that. So these exponential functions with exponential growth, like if you raise it a percentage each year, like 15% per year, or even anything above 6% per year, your money grows very, very fast. I mean, in only 25 years, you have, let me see, 26,000 divided by 800. It grew over 30 times as big, okay? Over 32 times as big. So it is amazing what exponential growth does to your money. So learning mathematics is good, man, because it teaches you the power of investing. Now, there are different ways to invest your money, and one situation is this right here. So let's take a look at it. It's a little bit different. So here now you have $800 initially as well, but something different is going to happen right here. It says if you have 800 initially and you invested your money in the bank, each year it increases by 50 bucks, not 50%. We're talking an increase of 50. So we're going to add, okay, we're going to add $50 every year per year. Okay, so let's work this out. After 1 year, you have 850 bucks. And then again, we're adding 50 here. Okay, add 50 again. Just do the arithmetic. So 900, 950, 1,000, 1,050 bucks. And that's after 5 years. Compared to the previous situation, just look at the difference here. Okay, so growing by a percentage versus by a fixed amount is a totally different situation. And this right here, this is your delta y, and your delta x here, that's 1. So this tells me that the rate of change here is equal to delta y divided by delta x here, as we talked about earlier, and that's 50 divided by 1, or $50. The rate of change is 50 bucks every year per year. Now, because of that, if the rate of change is constant, and you're dealing with addition here, okay, you're dealing with a linear function, okay, because the rate of change is constant. So it's a linear. Why? Because the rate of change is constant by addition. If we dealt with multiplication like we did earlier, well, I'd say it's probably exponential or something else. Okay, now because it's linear the function looks like your famous y equals mx plus b, and we know the slope here, again, the rate of change of slope is 50. So this tells me that I start off with y equals 50x. But we know the initial value here is 800, and that's your starting point, and that's always the y-intercept. If you substitute 0 in there, you get 50 times 0 is 0. You would have to add 800 to get to the 800 to your initial point. It's your initial value. Okay, so we have our function here, our linear function here, and now you needed to predict it. Like, what would you have in 10 years? You know, what would the y value be? Okay, so let's take 50, all right, multiply it by 10, and then add 800. Okay, again, I'm just using the function. So let me see, that's 500 plus 800. That kind of sounds like $1,300 in the bank after 10 years. After 15 years, and again, we're dealing with years here, you know, what do you have? Well, you have 50 times the number of years plus 800 more. So what is that? Well, let's figure it out. So 50 times 15, all right, that's 750. So 750 plus 800, that kind of sounds like 1,550 to me. So let's just add 800 here. Notice that I'm using the calculator here, and I get $1,550. So don't worry about it. If you can't do all this in your head, obviously do it like I'm doing here. Do the calculations off to the side, and then obviously learn the mathematics. Okay, so check that out. That was a different situation than the previous one because we're dealing with, you know, a linear function here versus an exponential function. So you have to be able to change and go with the flow and really understand your mathematics so you can, you know, apply the different skills. Okay. Now again, all of this is review. Okay. So let me go back. I've been going fast here, but remember when you watch a video here and you're checking solutions, you pause and play. All right, and you go at your own speed. So pause and play, rewind if you need to, rewind if necessary here, and then go at your own pace. Go at your own pace. And remember, this is a video and I'm doing this to help you guys out. So use the technology properly. And if you have to listen to it again, because I may go a little bit too fast, do it. Okay, I do the same thing, by the way, when I watch other people and learn something. Because Mr. Aynesworth here is a constant learner. Okay, so at this point, what do we have here? We've got the data represents, I tell you it's exponential. Okay, so it's exponential. We want to analyze the rate of change and define the growth factor. So we have to use some basic skills that we used before here, and then use the y-intercept here. Okay, secondly, we need to use the y-intercept to help us write the exponential function, unless you already know it. So, all right, so let's go for it. So the rate of change. So here it's exponential. So because it's exponential, okay, the rate of change, your growth factor here, if things are increasing over time, so let's call it a growth rate, or growth, yeah, let's call it a growth rate. All right, that's equal to the second y value divided by the first y value. So the first y value is 24, the second y value is 43.2. And to figure out your growth rate, you got to divide the two, right? So let's do that. Let's take 43.2, divide that by 24. And again, you don't have to do this stuff in your head. Right? When it comes to exponential functions, you get to use your handy dandy calculator. So let's just take 43.2 and divide it by 24, and you get 1.8. So what we have a growth rate of 1.8, which means we simply multiply by 1.8 all the way through. And if you don't believe me, okay, take 24, okay, multiply it by 1.8, and notice you get 43.2, which is your second y value, times 1.8, you get your third y value. Okay, your third value here, just take a look at it, 77.76. So we have a growth rate right there. And now we understand that we have an initial value. The initial value is always at 0. So there's your initial value. You can substitute in and solve for it, but you should know by now that uh, we have an initial value of 24. That's your a value. And when you put these two things together, knowing your exponential function is always a times b to the x power, all right, we have y is equal to your initial value, 24, times your growth rate, 1.8 to the power of x. And there's your exponential function. All right, and if you want to check that, it's real simple to do. You type it in, so y equals 24, all right, times your growth rate of 1.8, and then take it to the power of x. And then what you do is you click on the gear, change it to a table, and you fix your values. All right, and so you go 0, 1, 2, all the way up to 7. And if you just click on there we go. And those are the same numbers. Okay, so you can tell that it's the correct function. And that's how you check using Desmos. And I showed you guys that in class as well. All right, so I'm just going to bring this in just so you can see it here. So we have record of what we do. Just click copy and delete. And then paste it off to the side. Click text box, paste it off to the side, and you can see what I'm talking about. Look at that. Isn't that sweet? All right, and there's record of your first one right there. So that's a little iPad skill that you should learn how to use, because we're going to use it in more advanced applications later on in semester 2. So get good at it, and you can use your technology like Desmos really effectively in your learning development. Okay, there we go. Learn how to use Desmos. It says use Desmos to confirm. I just showed you. Okay, number 4. Okay, so similar thing, but we have a growth function because it goes up and all the y values are increasing from 60 to 75 to 93.75 to 117 and 146. So they're increasing. So how do you get from this y value to the second y value? What do you multiply by? Well, you gotta analyze the growth rate, right? So let's do that. So the growth rate, again, as I said before, y2 divided by y1. Okay, and this is your b value in your function here. So y is always a times b to the power of x for your exponential function. Okay, so let's do it. So y2 is 75. We have y1 is 60. So let's figure that out. So we go to the next row, and you take 75 divided by 60, and voila, you get 1 1/4, 1.25. Okay, so you get 1.25. Now let's confirm that. Let's see if we keep multiplying by 1.25, which is our growth rate, do we get the next one? Let's see if we're correct. So we start off with the initial value of 60 times 1.25 times 1.25. And notice I get the third y value, 93.75. But do we get the next y value? I don't know. Let's find out. So times 1.25, and well, you got to type it in correctly. So there we go. Now I fix that. And notice we get the third y value. Okay, so this is the fourth one. Excuse me, the fourth one. And again, it just goes over and over and over. So now we need the initial value. Again, at 0 is called your initial value. Or you can say starting value, whatever you like. So that is 60. So now I know B is 1.25. Okay, I know the initial value is 60. And all you do is write your function. Y is equal to 60 times your growth rate, 1.25, because it's bigger than 1 there, and raise that to the power of x. And then you check it. Okay, so y equals, all right, 60 times 1.25, and raise it to the x power. Now when you check it, you got multiple things going on. Notice I turn off the colors there, so I only look at one function at a time. Click on your gear, and then the table, and then fix your values, as I'm doing now. And notice the values right there. There's your function. And all these values here are up on the screen. Okay? So again, I'm going to screenshot this and bring this into my lesson here, just to show you. Okay, the power of technology here. And I'm going to put that off to the side. So click text box, press and hold with your finger, paste it in. It's a copy paste feature. And then resize it, and you have it right there. Look at that beauty. Okay, so check that out. So that's how we do it. Okay, and then that's number 4. This is an example of an exponential growth function because it goes up. Things increase over time. Exponential growth. It increases exponentially, which means super fast. Okay, there we go. And that's number 4. And like I said, this is a video, right? So you can always pause, play, rewind, listen to it again in order to master it. Okay, we got a few more to do, so let's keep it rocking. Okay, now when you notice that the values decrease right here, okay, it's an exponential function, but in this time it's decreasing, so we're talking about an exponential decay function. So we need to find the rate of decay. So here, let's find the rate of decay because we're given an exponential function here. And you do it the same way you did before. You take y2 divided by y1. So y1 is 500, y2 is 250. Okay, and you get 250 divided by 500. And if you don't know what that is, well, it looks like a half to me, but just go ahead and type it in. All right, and you can see it's 0.5. 0.5 is 1/2, you guys. Okay, half of 500 is 250, so that's 1/2, or you can say 0.5. And there's your rate of decay. So we're taking everything and multiplying it by 1/2, and everything gets half as big. That's why things are getting smaller as opposed to bigger. And let me just change this. I didn't mean plus, I meant times. So times 1/2, times 1/2, times 1/2. And again, you put your numbers in, your starting value is 500, and then you multiply it by 0.5 times 0.5 times 0.5, and you can see the numbers get smaller and smaller and smaller. Okay, so then my exponential function always looks like a times b to the power of x. My initial value is given to me because when x is 0, you get your initial value. So a is 500. So a is 500. That's my initial value. I know my growth rate b is 0.5. So my function looks like 500 times 1/2 or 0.5 to the power of x. There you go. And if you want to check it, no problem. So y equals, we start off with 500, multiply it by 0.5 if you want, and raise it to the x power. Click on the gear, change it to a table, and then change your values. And there you go. There's your function. So I'm just, you don't have to screenshot if you don't want, but you know, if you want to remember how you're doing this, you can do what I'm doing. Press text box, press and hold on the side, paste your decimals in. And so you remember how things are done. All right, using your technology, which is important in this case. And so there you go. All right, number 6. Let's keep rock and rolling. We got another decay function. Okay, the initial value is 1600. So notice that I give it to you. Initial value 1600. That tells me that a is 1600 in the exponential function. We need to find the rate of decay again. So rate of decay, as I've said multiple times, is my second value divided by my first value. So it goes from 1600 to 400 to 100 to 6.25 to 25. So to go from here to here, what do you multiply by? Well, let's find out. So we're going to take our second value, which is 400, divided by 1600. And if you simplify a little bit, okay, you get 4/16, or 1/4. If you did it with a calculator, you get 0.25. So if you use this right here, you take 400 divided by 1600 if you use the calculator, and you get 0.25, which is 1/4. Okay, so we have 0.25. There's your rate of decay. B is 0.25. Okay, now your function is always a times b to the power of x. All right, we know our a value is 1600, so 1600 times 0.25, or you can say 1/4 to the x power. So in fractional form, you have 1600 times 1/4 to the x power, same thing. And there we go. And then again, you can put that in decimals if you like. Oh, what the heck? Let's just do it while we're here. Okay, so here we go. So to show you how easy it is. So y equals 1600, all right, times your 0.25 and raise it to the x power. Click on the gear, change it to a table, and change your values. As I keep on saying, all right? Once you get the hang of this, it's super simple. But you know, it takes a lot of practice what I'm doing right here, but when you get the practice and you do the right thing, it actually is quite simple. Okay, and that's why we always practice in class with the whiteboards, you guys. Because if you just listen to me, you're not going to get good. If you actually practice in front of me, all right, then you'll get really good. Okay, so there you go. There's number 6. Okay, only a couple. Oh, geez, we got a few ago. This is longer than I thought. Okay, so number 7. This is from our, again, I took all of these from our previous lesson. So we have our figures here. So the figure number here is figure 1, figure 2, figure 3, and right here, given this visual pattern here, you know, how many, what's the rate of change in the number of cubes, what's the function, and then here we want to determine the number of cubes in the 75th figure. So when x is 75, you know, what's y? What is that? Well, there's obviously one cube first, and if you count the one underneath the top here, there's one underneath that plus 4 more. There's a total of 6. And then you're adding cubes on all sides and also on the top, so you're adding 5 more. So here the change is 5. So we have 11 here. So in our first figure, we have 1 cube. In the second figure, we have 5 cubes. In the third figure, we have 11 cubes. So the rate of change is, oops, I didn't say that right. We have 6 cubes here. Sorry. In the second figure, we have 6 cubes. In the third figure, we have 11. So the rate of change is 5. From 1 to 6 is a plus 5. 6 plus 5 is 11. And that's called delta y, or the change in cubes. And the change in the figure number is obviously 1. Okay? So the rate of change is always delta y over delta x in a linear situation here. So we have a 5 divided by 1, or a change in 5. Why? Because we're adding 5 cubes. All right? It's a change of 5, guys. And then the function, it looks like whenever you add something constantly, so this is called a constant rate of change. Constant rate of change here. All right, we have a linear function, y equals mx plus b. Now the rate of change is your slope, all right, which is m. Okay, so that number here goes here. So we start off with y equals 5x, where, you know, x stands for the figure number and y stands for the cubes, but that can't be it. No way, all right? So So you substitute 1 in there, substitute like your first order pair in here, like 1. So when x is 1, y should be 1, right? When x is 1, y should be 1. So what do we have? We have y is equal to 5 times 1 is 5, but I need 1, so I got to subtract 4, right? And that will give me back to 1. So my linear function here should be y equals 5x minus 4, and then we use it to calculate the number of cubes in the 75th figure. So you substitute it in there. So 5 times 75 minus 4. So whenever you do something here, if you want to use the calculator, go for it. All right. It's not going to help you to know what to do, but it's going to sure help you with the calculation. So just type it in and notice you get 371 cubes. All right. In the 75th figure. Again, that was from our former lesson. This is a review problem, guys. Okay, so again, you start counting using the visual pattern. All right, organize it, find the rate of change, find the linear function, and then use it to predict. That's it. We did that like so many times. Let me show you. So let's see here. Oh, look at here. Oh my gosh, look at there. It's this problem right here, but I just changed it slightly. Okay, I changed it from the 50th to the 75th. Okay, like I said, we're reviewing. Okay, next one and last one. Oh, not the last one. We've got a few more to go. Okay, so in this one here, given the linear function here, so y equals 2/3 x plus 1. What's the rate of change? Graph the function. Okay, so here we go. So let's substitute the values in. So my function is y is equal to 2/3 times whatever x is, and then plus 1. So here we go. So negative 2/3 times negative 6 plus 1. Well, negative 2 times negative 6 is 12. Divided by 3 is 4, plus 1 is 5. And you just want to keep this going. So you substitute the next number in and you follow the order of operations, right? Okay, so negative 2 times negative 3 is 6, divided by 2 is 2, plus 1 is 3. Next one, negative 2/3 times 0 plus 1, that's got to be 1. So negative 2/3 times 3 plus 1, be careful here. Negative 2 times 3 is negative 6, divided by 3 is negative 2, plus 1 is negative 1. And negative 2/3 times 6 plus 1, what's that? Well, negative 2 times 6 is negative 12, divided by 3 is negative 4, plus 1 is negative 3. And last one, negative 2/3 times 9 plus 1 is negative 18, divided by 3 is negative 6, plus 1, well, that's negative 5. And then you plot the points. When you graph, and the rate of change, well, what's the rate of change? Well, let me see, I have a delta y of minus 2. I have a delta x of a plus 3. From negative 6 to negative 3 is plus 3. So my rate of change is delta y over delta x, which for me is negative 2 divided by 3, which corresponds to this right here. Okay, so they match. And now all you do is graph the function. So let's plot your order pairs. So go left 6 up 5, left 3 up 3. And again, we're just basic skills of plotting. 0, 1 is up 1. 3, negative 1 is right 3 down 1. And then 6, negative 3 is down here. And then 9, negative 5 is right down 5. And then, of course, you draw your function. Okay? It's a linear function. It's a line. Okay? It's linear. Linear, when you graph it, okay, becomes a line when you graph all the order pairs. Okay. And last set of problems here. This is from, again, a previous lesson. So here you have a linear relation. All right. Find the slope, which is your rate of change, which is your delta y divided by delta x. And then you want to write the linear function and find your values. Okay, so here we go. So On the change of x, we have plus 2 all the way through. That's your delta x. Your change in y is 4. That's consistent through here. So your slope, or your what's called your rate of change, is delta y over delta x. That's 4 divided by 2, or 2. And remember, for your linear function, it always y equals mx plus b. And because you know the slope is 2, you start off with 2x. And then again, you have initial value here. When x is 0, if you substitute 0 here, you have 2 times 0, which is 0, but you need a 5, so you have to add 5. So we know our linear function is y equals 2x plus 5. And once you know your linear function, you substitute it in. So 2 times 12, and then add 5. So what is that? Well, 2 times 12 is 24, 24 and 5, 29. Next one, 2 times 18 plus 5. That's 36 plus 5, or 41. Okay, and those are your y values. And it says find the slope, which is the first thing you need to do. Find the linear function, find the y values. So you have 3-step process here. Okay? Now, again, you should have already done all this. So here you're checking, or if you're watching me and you're getting help, pause and play and go at your own pace. So you notice on example 2, delta x is 4, delta y is 2. So your slope, which is the rate of change, is always delta y divided by delta x. So you get 2/4, or 1/2. So your function looks like y is equal to 1/2 x. That's how you start. And then you know your y-intercept here. If you substitute 0 in, you need a 3. So you have to adjust it by adding 3. And then, of course, you get your y values. So now you take 1/2 times your x value and then add 3. Half of 20 is 10, plus 3 is 13. And then you got to take a half of 26 and then add 3. And that's 13 and 3, that's 16. Okay? And we just have one more to do. But the idea is the same. You find your change in x first, which is 3. You find your change in y here first. From 1 to -8, you got to subtract 9. And here you got to subtract 9. And here you got to subtract 9. So delta y is -9 because you're decreasing, you're getting smaller. So your slope, which is your rate of change, as I keep saying here, is always delta y over delta x. And that's a -9 divided by 3, or a -3. So you start off by saying, okay, the slope's got to, or the function's got to be y equals -3 times x. All right? And then you know your y-intercept is 1, or your starting value is 1. So if you substitute 0 in, you get -3 times 0, but you need a 1, so you have to add 1. And there's your function. And then you use your function. So -3 times your x value, you got to substitute that in, and then add 1. So -90 plus 1 is a -89. And then over here, you get -3 times 40 plus 1, which is a -120 plus 1, or -119. Okay, so this takes some practice. And that's why I'm giving you guys, because you need to do a full review. This is a full review over the lessons we studied over the last few weeks. And the only thing you guys need to do is get good. And the only way you get good is by pure practice, my man. Okay, so do yourself a favor, practice, use the video resources, pause and play and go at your own speed. All right, make yourself proud, and I'll see you on test day. This is Aynesworth. Bye-bye.